Hello, hello, hello. This is Will. Welcome back to From Bronze to GM and miniKanren. It's been a little bit. I did the first 9 episodes in 5 days. First 9 episodes in 9 consecutive days. And now it's been, I think, close to 2 weeks since I recorded a video. But today I can record a video. So we're on to episode 10. All right, so we had some ladder practice from last time. At the micro level, it was to read the Scheme Programming Language 4th edition by Kent Divig. Those sections on quote, quasi-quote, unquote, unquote splicing, and play around with these in the REPL until you can do it. Okay, so what does that mean to do? To do it, first of all, it means that you can use these things effectively. And, for Scheme, which is a Lisp, and Lisp stands for list processing, the ability to create lists and nested lists are very important. In a language like Clojure, my understanding is there's much more use of other data structures in Clojure. In Scheme, you still have the cons pair as a very fundamental atomic entity. I mean, it's not atomic. You can get the car encoder, but you know what I mean? It's like, it is like the essence in some sense of everything you have in Scheme. There are other data structures in Scheme, but if you're doing like R5RS, right? If you're doing old school Scheme, you're going to be using cons a lot. And the bottom line is we use S expression syntax in Scheme. And so you need to really understand what it means to see a dot and what it means to construct, a nested list or tree structure with a certain form. You need to be able to do this stuff in your sleep. Okay. You have to be able to do it. You have to be comfortable looking at quasi-quoted expressions, quoted expressions, consing things. This is just bread and butter. And when we get to recursion and pattern matching, you really have to be able to do these fundamentals of consing up a list, understanding how to read a quasi-quoted expression, all those sorts of things, or you're going to fall apart once we start doing recursive programs. Okay. As it gets harder and harder, you'll need to really have these rock solid fundamentals to anchor you. So anyway, my definition of being able to do it isn't that you can occasionally do it, or you can do it 50% of the time or 70% of the time. It's that you can do it tired, hungry, sleep deprived, mildly annoyed, using someone else's computer with a setup that's not your own, where the paren matching is turned off and things like that, and you can still do it. Okay, you could still do it quickly with very high accuracy. You just have no problems doing it, and your accuracy rate is really the most important thing. It's more important than how fast you type, let's say. Okay, it's more important that you get used to being able to do it right, and then the speed will come later. But like if you're consing up a list structure, practice and make sure you can do complicated consings, that are nested and things like that you can get that to be, sort of completely mechanical and something you can just do in your sleep. And then, if you keep practicing that, you'll get faster and faster. Now, I don't know, maybe you're a natural, or maybe you already know how to do this. Okay. In which case that's fine. You can always get, even faster and more accurate. At some point you'll be fast enough and accurate enough. But my point is, this is like in StarCraft, not getting supply blocked, right? It's like really, really bad to be supply blocked. Not being able to cons up structures, not being able to read a quasi-quoted expression or build a quasi-quoted expression properly, that's like being supply blocked. You'll try doing something hard, and it's like, hey, why can't I write this recursive function in a reasonable way? Why is it so frustrating? It's like, yeah, because you don't know how to you don't know how to use quasi-quote, or you don't know how to cons things, or you're confused about how lambda behaves or something like that. Okay, so you just have to have these fundamentals, and they're very elementary, so they can be a little. I mean, it's sort of good and bad news, right? So the good news is these are very elementary things, and you can learn them. You can learn them inside and out. It just requires a little diligent practice. The bad news is that they're elementary things, and they could be seen as boring in the same way that practicing StarCraft to make sure you're not, Overlord blocked or something, maybe seen as boring. I don't know, but you just have to be able to do this. You have to be able to look at a paper that has a quasi-quoted expression, or look at code that has a quasi-quoted expression, and really understand what's going on. You can't wing these things. Okay, this isn't vibe coding. Not talking about Vibe the streamer, but Andre Karpathy has this idea of vibe coding. You don't want to vibe code this. You just absolutely have to be able to do this in your sleep. Okay, and we'll take a look at this. Okay, we'll take a look at quasi-quote in the Scheme programming language, because I just want to show you how we can look at something like TSPL, okay, and do a little practice. But that's important. You have to be able to do this, okay? The good news about Scheme is that you can program Scheme in this very elementary fashion with very few parts. Okay, so that's the great part of it. The counterpart to that is you have to know those parts inside out. You have to be able to, do here's one question. Could you do the programming in your head? If you're taking a shower, could you write the program in your head and be able to just type it in and have it work correctly the first time? Right? That's the level you want to be at. It's sort of like a chess player, at some point in chess, you can start playing games in your head. That's the level we want to be with this, where you can just write code in your head, or someone can just tell you some code, verbally, backquote, blah, 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 blah. And oh, okay. They'll say quasi and then something, and then you'll know exactly what they mean and be able to think about the code, right? So that's where you want to get. It's not just sometimes you can do it, or if you squint at it, you can figure it out. It's you need to be able to do this in your head ultimately. And if you can't do that, then keep practicing. Okay. Keep practicing. Okay. For macro, read about one or more of advice taker, AM, Eurisco, Psych, truth maintenance systems, propagators. So these are classic, good old-fashioned GoFi AI systems, and they all have some connection to Lisp, to some of them to Scheme. And I think they're interesting because they're from the 1950s, 70s, and 80s. I don't know if any of these were done in this. I don't think any of these were from the 60s, but some of the work you could probably trace back to the 60s. But going back to the late 50s with Advice Taker, McCarthy's Advice Taker, you can see what people were trying to do with Lisp, with various sorts of Lisps, and the role of logic in something like Advice Taker. It's very interesting. Psych has all sorts of logic in it, and then different sort of meta heuristics and like in Eurisco. Very interesting. And then TMS and propagators as sort of plumbing for building intelligent systems. So I think these are interesting for several reasons. One is Lisp wasn't created in a vacuum. Scheme wasn't created in a vacuum. They were created as languages for writing software that, for which you could build AI applications. And it's interesting to see the sorts of applications people had in mind or were trying to build. It gives you a lot of insight, I think, into the language design and trade-offs. And also, what were they trying to build? And also now that there's been so much progress in other areas of AI and the hardware is so much more advanced, and we have things like SMT solvers we can call out to, and fancy data structures and compilers and all that, what could we learn by going back and revisiting these systems? Now, propagators are relatively new. Okay, so but they're still, I think, underexplored in a way. But advice taker, that's from the late 50s, and as far as I know, that was never actually, no one ever tried to build it, as far as I could tell. So, anyway, that was your macro homework, and there's a lot of this sort of work. Things like Eurisco come into what are called discovery systems. There's a lot of work on discovery systems. There's also the Programmer's Apprentice, which came out of MIT. As like sort of late 70s and through the 80s, and then some work actually relatively recently, some proposals to revisit it. So a lot of these systems, if you want to learn about these, find an old AI book or read about the history of AI, and you'll find these systems. But then, go off and actually read the papers or read the book. There's a book on the Programmer's Apprentice, by ACM Press. So anyway, keep doing this, okay? So the micro part, this is like pylons and probes and not getting supply blocked and all that, right? And then the macro, this is like, how do we change the metagame? What sort of possibilities are there that people explored? Maybe in chess, the analogy would be the hypermodern, approach to chess, where you do things like control the center indirectly, those sorts of things, or provoke your opponent to advance their pawns so far that they can't defend the pawns, that kind of thing. So anyway, this is more like high-level ideas and what might be due, and this is more like, here's the nitty-gritty, and they come together because just like you need to make sure you're not getting overlord blocked. It's like, hey, I'm going to do this great strategy and this and this and that. They're like, well, yeah, you forgot to spread your creep and your overlord blocked and whatever. And so your great strategic idea, you never got to see if it worked or not because you couldn't even do the basics, right? So same here. It's like you might have this great idea. I'm going to revisit advice taker. Okay, and I'm going to do it all in scheme. Excellent. But then you don't know how to use quasi-quote, or you have trouble consing up things, or you don't know how lambda behaves, or, you don't know the evaluation rules of scheme, or something like that. You know these things a little bit, but they keep tripping you up. Well, that's like getting supply blocked or not spreading your creep or whatever, right? So it's like you have to have both, I think. Now you could say, well, maybe I just want to learn scheme really well, or just want to learn miniKanren really well, and I don't care about the high-level ideas. Like, okay, well, fine, but I'm going to talk about the high-level ideas as well, because I think if you want to understand language design, where do languages come from? Where are the ideas behind them? What are the trade-offs and things like that? You can't understand that without knowing why people created the language to begin with, and what sort of uses the language had that shaped the development of the language. So to me, you can't really separate these things. The fact that the idea of quasi-quote came from supposedly the logician Quine, right? So there's logic all over. The imprints of logic are all over Lisp. McCarthy was really big on logic. Logic inspired a lot of what's going on with Lisp. And then there's this whole school of metaprogramming and macros and all these things. So I think intellectually and philosophically, the Lisp family of languages is very rich. So anyway, keep up with your macro and keep up with your micro. It's like, okay, say you already know scheme fairly well, challenge yourself. I mean, this is what I would do. I would challenge myself and I say, okay, here's a complicated expression. I just sort of wrote down randomly. How quickly can I cons that up? Can I do it accurately? Time myself to do it 20 times as quickly as possible. What's my success rate? Is it 100%? Can I do it as quickly as I could type 100% of the time? Or if not, how quickly can I do it and still have at least 95%, but ideally 100%, right? So I was always trying to go towards 100% accuracy. And if I couldn't do it 100% accuracy as fast as I could go, even 95% is not that great, to be honest, I would slow down until I could hit 100%. Can I do this 20 times in a row without making a single mistake? And then over time, I could get faster and faster and faster. Okay, so this is like the day 9 theory of mini games. Okay, so there's a mini game in Scheme having to do with quasi-quote, and I'll show you like it really is a mini game because quasi-quote is more expressive than you might think. Quasi-quote is very interesting. So there is a whole mini game just about quasi-quote and quotation and, quote and quasi-quote and unquote splicing together. That's a whole little mini game in Scheme. And you want to reach a certain level of proficiency of that. Okay, you don't want to be tripped up by stuff like this because you're trying to implement something and you need to use unquote splicing, or that's the right thing to do here. And you don't know about unquote splicing, or you don't know how it works. You should know that exists. You should know basic uses of it. Okay, maybe there are more advanced uses that you don't have off the top of your head. That's maybe not so important, but it's very important that you know how to look those up. Okay, so maybe you don't use unquote splicing very often. I don't use it very often. I use it in a very basic way most of the time. It's pretty simple, but there's some idioms using quasi-quote and unquote splicing and things like that that are more complicated, but I know where to look those up. Okay, so that's just an important skill in general. Like knowing unquote splicing exists, recognizing a use of unquote splicing, recognizing where you might use unquote splicing, and then looking up, knowing where to look up, and being able to, and actually doing so, looking up the details and examples. That's really critical. Okay, so that's the sort of thing that we have to do when we're programming in an elementary style, I'll say. Okay, so Richard Feynman would talk about this sort of thing, elementary proofs. That doesn't mean they're simple, doesn't mean they're easy, but they're elementary. They're not using a lot of parts. And so in Scheme, I like to do a very elementary style of programming in Scheme. And, if I want abstractions, Scheme gives me nice procedural abstractions. I can do, data hiding with Lambda. I could also use records if I really want to. And then there are things like, well, first of all, procedural abstraction gives you a lot, but then there's things like macros. Okay, so, and then you can also write interpreters, stuff like that. So you have a lot of language-based or meta-programming-based abstractions over an elementary core. So that's what, to me, makes Scheme so appealing, is that you have this very small elementary language that you can really understand and implement all those sorts of things. You can really understand it backwards and forwards in a way that larger, more complicated languages, it's hard to understand. Languages that are less elementary. But then you have incredible powers of abstraction. So anyway, but the thing is, you have to know the elements inside and out. You can't skimp on it. Okay? Can't skimp on it. Oh, yeah. So I was going to make this video yesterday. I tried it a few times last night and didn't make it. Once again, I was looking at the news too much and things like that. And today I started typing in NYT on my phone. Let's see what the New York Times has to say today. I'm like, no, I'm not doing it. I'm not doing it. So there's this classic 80s song from Hall & Oates, Out of Touch. And there's this internet meme, Out of Touch Thursdays, where you listen to Out of Touch on Thursday. So this is my Out of Touch Sunday. I refuse to have anything to do with the news today. If at all possible, I'm not going to seek out anything about the news today. Tomorrow I can deal with it, but right now, to do a Firefly quote or Serenity quote, it's beginning to damage my calm. So here's my Out of Touch Sunday. And yesterday I did a fair amount of laddering. Laddering is a good way I find to get out of my own head, because I'm trying something as hard as I can. It requires my absolute 100% attention when I'm playing StarCraft on ladder. So that's the good and bad part. I mean, when I was playing a lot when the game came out, it's like, wait, what happened to the weekend? Or at 6 a.m., maybe I should go to sleep. But it's also kind of a good way to kind of get me out of myself. I also find lead climbing for rock climbing also very good for getting out of your own head. It's like, hey, I really don't want to fall right here, right? Where do I put my hand next? It just forces you to pay attention in a way. And also, when I was hacking in miniKanren or Scheme, on like a research problem at the very edge of my ability, I don't know if you technically call that flow state. I guess so, because I think it has the hallmarks of flow state. But that would also get me out of my head, as long as it was going well. Now, I will also say that sort of like, losing a bunch of StarCraft games in a row by being cheesed out by Protoss Cannon Rush or whatever, you could definitely get a little upset if things aren't going well. I've gotten better with laddering. It doesn't bother me too much. I very rarely get upset by losing a game now. It's more like, let me watch the replay, because that felt weird to me. I didn't understand why the other person could get away with that. So now it's more like a curiosity thing. Whereas if I'm hacking miniKanren or Scheme and I think I've got this great idea, then I sort of get into the artist mindset, which I'll talk about a lot more in a minute. Where it's kind of tricky, right? Because you've got this thing and it seems like maybe it's promising, but maybe it's not. Oh, it's terrible. Throw it all away. But no, it's great. And, get into that. that is still tricky. I mean, but it does get me out of my normal headspace, I guess. And from the Big Lebowski, I'll paraphrase the dude. Fortunately, I've been adhering to a strict StarCraft laddering regimen to keep my mind limber. So this episode is episode 10 is brought to you by my strict StarCraft laddering regimen and my out of touch Sunday. It's not brought to you by the news. Okay, I've been watching Vibe's 2021 Beta GM series, and one thing is that he talks about, which resonates with me doing this series, is that he's worried about sounding like a broken record, because he keeps saying the same things over and over again. They might be said slightly differently. He might play different games to explore those themes and to show it off. But there is, there's both some messages he's trying to communicate, and also he's trying to overcome what he sees as resistance on the part of people to those messages. He's done a lot of coaching and things like that. And, I myself slipped into the micro instead of macro mode a number of times yesterday when laddering, when I get thrown off by some sort of early cheese or something, it's like, okay, I gotta counterattack with my roaches. It's like, go back and spread the creep. Come on, But one of the things he said was, he talks about playing efficient, and he's just like, well, macro. What does macro mean? People will say they're macroing, but what he means is playing efficiently, like saturating the mineral lines before putting 3 workers in each of two gases, right? That's 8 drones. 2 drones to make the extractor, and then 6 drones to mine the gas. You could have had 8 drones on minerals, and players who are mineral block the whole game. And they're like, well, what happened? Why did I lose? Did I pick the wrong unit? It's like, well, you didn't mine anything. You didn't have any minerals. You were floating 2,000 gas and you're out of minerals. Like, what were you trying to do? So, and he says this efficiency, this attempt to become more efficient never stops. Okay, so if you're a grandmaster, if you are a pro, you're still trying to be more and more efficient. And so it's not like this is a bronze league thing and then you're done with it. It's not like you become efficient and then you stop. And that, both the broken record part and the efficiency thing, resonates with me. Things like, okay, at a certain point, you can do quasi-quote and unquote splicing in your sleep, and you can cons things up, and you could write a scheme interpreter in your sleep and all that. Okay. What about a scheme compiler? What about an optimizing scheme compiler, or whatever it is you need to know how to do based on your, the area you're doing research in? Can you understand those ideas or search, search and logic programming? There are lots and lots of ways to do search, and there's been a ton of research on it, and a ton of systems that were implemented. So just learning how search can work in logic programming, that's something you could spend, a whole career just studying different search techniques, right? So it's like it doesn't end. You're always trying to understand these ideas at a deeper level and become more proficient at doing these things. If you're writing an optimizing compiler, you'd better have a good sense of which optimizations are sound and which aren't, things like that. So you really need to know the language semantics, and you need to know how the optimizations interact with the semantics of the language. And if the language semantics changes, does that invalidate any of your optimizations or make other optimizations now possible? Stuff like that you really have to understand. If you're going to assembly language, do you understand how that works? If you're trying to program for an accelerator, do you understand the memory model for the accelerator? All that stuff. There's certain fundamentals you have to keep improving your understanding of and your proficiency with. So, and also, just sounding like a broken record. Yeah. So I'm going to harp on the ability to do fundamental things, elementary things like concept structures, use quasi-quote, write recursive procedures, those sorts of things. That's like really bread and butter. But also, I talk a lot about sort of the mental and emotional, psychological aspects of doing research. And I think that's really important. And that also never stops, okay? It never stops. I've talked with plenty of very, very experienced, famous researchers. They talk about how hard it is, just like sort of the psychological aspect, because you're working in a domain where you're often failing at things, and also, especially in the beginning, but even when you're more established, you'll have some idea that you think is really cool, and you'll try implementing it, and you'll show things to people, and they'll either say, I don't get it, or they won't reply at all, or they'll say, that doesn't make any sense to me, or why don't you just do this other thing, or there's already a solution to this problem, why are you doing it? Whatever. And maybe the idea isn't that great, or at least the way it's executed, or maybe it is, and you just haven't communicated it clearly, or haven't talked to people who are open to understanding the idea. But that also never stops, having to communicate ideas that are ill-formed to you, or that you're communicating to people who don't have sort of the analogies in their head yet that allows them to easily see what you're trying to do. Or maybe you don't have the applications yet. Maybe the research isn't to the point yet, or the idea is not to the point yet where you can show something really compelling to someone. That's part of the problem of say you had this great new computer architecture that you think's way more efficient than anything being done today, and there are a number of people who have claimed that this is true. Part of the problem is the current CPU manufacturing processes have been optimized over decades, and even if your approach maybe scales better ultimately, you have an awful lot of work to catch up with before you become anywhere close to competitive with the state-of-the-art, say Intel processors, even though Intel's probably not the best processors anymore. So, that's very difficult. and it requires people, who look at your work to have some imagination and to think, okay, I could see this being pushed for a very long time. Sort of like first flight of the Wright brothers, right? Someone seeing that and then thinking we'd go from that in 1903 to, landing humans on the moon 1969. So 63 years later, we'd be landing on the moon. That's a stretch, right? So you have to have some imagination to somehow tie those two together. Now, of course, we didn't go to the moon in an airplane, but the point was, we had things like the X-15 that, that was kind of an airplane, a rocket airplane. There were all these kind of weird hybrids. And then there was stuff like the space shuttle that, kind of was like an airplane when it landed without engines. Anyway, certainly it's hard to imagine an Airbus A380 flying over the North Pole at 40,000 feet or whatever. Yeah. So none of this ever stops. You never stop trying to become more efficient, as I would call it, in terms of understanding ideas more fundamentally, having a deeper insight, being able to manipulate those ideas and riff on the ideas better. Just like, someone who seriously studies music, it's not like they ever, oh yeah, now I know everything there is to know about music. I'll never, try to innovate or understand more. It's like, no, keep pushing it. And that's the same with the sort of mental, emotional, psychological part also, I think. One reason I've been thinking about this is last week I had a couple conversations with friends who will remain unnamed, but one was, how do you learn, computer science stuff? How do you learn maybe researchy stuff? And another conversation was, how do you deal with the day-to-day life of, being a researcher? And I think, once again, that's something that never stops. The life of a researcher, and that doesn't mean, by the way, that you have to be an academic researcher. That doesn't mean that you have to have a job that has researcher in the title or anything like that. It just means that you were doing research and you were in that mode and working in that mode. And that's a hard mode to be in, because when you're a researcher, you are trying to explore things in a new way. And also, you might be working with other people as part of the research, but part of the research is going to be alone. Like, even if it's just what is your thinking and what's in your head. And you're going to fail a lot of the times. Most of the ideas you have probably aren't going to work out or won't lead to the things you're interested in. So you're going to have a very high failure rate, and it's going to be hard to communicate these ideas to many people. And people who are more pragmatically based, right, often will dismiss whatever you're doing as impractical or academic or something like that. One of the things I found was at a certain point, even though I had worked as a professional Java and programmer in industry, once I really started getting into things like Scheme and functional programming and stuff like that, I almost couldn't have a conversation with a practicing Java programmer in industry. It was so hard to talk about things that we both found interesting. It's like we just, because I would talk about, basically I was thinking about things that maybe people would use 30 to 70 years from now. It's like, okay, maybe 70 years from now, industry will adopt this. Who knows? Or maybe they will never adopt it. Whereas the practicing Java programmer was thinking, well, what can I do to make my job better or easier, or write the software in a better way right now? Okay. Or, maybe what's becoming hot, or what can I put on my resume or whatever. A very practical, pragmatic approach, which makes total sense given what they're doing. And my approach, I claim, makes total sense from a research standpoint, but we didn't have a whole lot left in between in that intersection to talk about. It was kind of tricky. So life of a researcher is, it's tricky. I think it's like the life of an artist, or someone else, life of a writer or filmmaker or dancer, or someone doing something creative. It's like a very different type of thing. It's like, go back to that quote of, we're not making hamburgers here. I saw a YouTube clip. It was David Lynch in a car talking to someone. He was working on some project, I guess a movie or something, but I think I get this right. The quote was, if it's not word for word, it's like almost exactly the same. He said, I have no idea what I'm doing. I'm so depressed, right? It's like, okay, that you could literally take those two sentences and, have those uttered by the words of most grad students, most PhD students. I have no idea what I'm doing. I'm so depressed. And as I've said before, I think part of the reason so many grad students are depressed isn't just that they're not paid enough and all the other things that come with grad school and the academic system. And, that's a big part of it. But there's another part of it, which is just, I have no idea what I'm doing, right? Like, as soon as you say, I have no idea what I'm doing, it's very hard to keep doing that, to keep doing the I have no idea what I'm doing, and have it not affect your emotional state or psychological state, like very, very deeply. And so here's David Lynch, who's both who is into transcendental meditation and, known as this great dreamer and, very, very people friendly and all that. And here, having these visions, communicating these visions. And he's like, I have no idea what I'm doing. I'm so depressed, right? That reminds me a little bit about when I went away to college for the first time. I'd done some college programs in high school, but, that was, even though it was at a college, it was more like being in high school, like, right? It's like you had a curfew and, hey, you're not allowed to do this. And when I went away to college for the first time, it was like, oh, wait, you mean no one yells at me if I don't go to class? I can go to the Art Institute of Chicago every single day if I wanted to, being from a pretty small town, like kind of a Rust Belt town, that was just kind of blew my mind. You mean I can go to the Field Museum, or I can go to the Oriental Institute? And that was a real struggle for me because, having that degree of freedom, going from very little freedom to that degree of freedom, was something I wasn't really ready for. Now, in some sense, looking back at it, I did learn a tremendous amount, but I also was on my way to failing out of college, and I switched schools and then did fail out of the next college. That it was like, okay, that was me struggling with the fact that I had so little structure compared to what I had before. No one was telling me what to do. They were, in a sense, like, hey, you're supposed to go to these classes and get good grades. But here I am living in a big city for the first time, surrounded by all these interesting people who, are interested in the arts and, dance and stuff like that. and it was like a mind-broadening experience. And going to class and grinding my homework problems were not that just wasn't appealing in the same way as like, hey, for the first time I have access to a great city, and I can go check out all the museums and stuff like that. So that, or all the architecture. Chicago's incredible for architecture. So eventually I kind of got that under more control. But that was like a real shock. And I think that's what happens. I mean, there are plenty of undergrads who don't suffer this as much as I did, and who do well. And, they really, take their studies seriously. And when I went back to school, I took my studies super seriously, and I was a very, very good student. But I really struggled with that in the beginning. No one's telling me what to do. It's sort of like working from home. If you're working from home and are largely independent, no one's telling me what to do. I'm not punching into a time clock. I'm not here in the office and talking to people over the coffee machine or whatever. I have to decide, like other than my meeting schedule, I have to decide how I'm going to use my time and use it productively, and what I get done. Right. So it's the first time I worked from home, which was quite a long time ago now. I struggle with that a lot. So, the life of a researcher is very much like that. And part of it is, I think the life of a researcher is even harder than, say, working remotely or, going to college. Because for a researcher, like being an artist or a writer, no one really knows what you're supposed to be doing. Not really. No one else other than you. And you don't know what you're supposed to be doing, right? Like, no one knows what you're supposed to be doing. It's not even clear what you're supposed to be doing. So that's a big part of the work, is figuring out what you're supposed to be doing. And there's also this aspect of, you might be working on something that you've been working on for several years that not too many people seem to care about. Okay. Or you have an idea, you want to do something, you want to create a programming language, or you want to create a proof of concept application, or you want to write a book, or you want to blog about something, whatever it is. You want to, submit a talk proposal. For the most part, if you're working alone, no one's going to notice if you don't do those things. If you're working with a group of people, they might notice. Okay. But even then, your group has to decide what to do. Do you write a paper about this? Do you do you try to create an application? Whatever it is, do you implement this programming language? How do you implement it? In any of those cases, you all could do something else instead, right? So you just have to make these decisions. And for research, a lot of the times, if you just didn't do it, not too many people would notice, right? So you want to write a book. Well, what happens if you don't write it? Well, unless you already have a signed contract, like nothing. No one will even know that you were going to write this book unless you talked about it, right? So that's part of the problem, is like, there's a struggle of, does anyone care? Is the book any good? All those sorts of things. And it's the easiest thing in the world to just like not do it or to abandon it, especially when it gets hard. And if you're writing a book, it will definitely get hard at some point. And you'll want to throw the book away, almost certainly at some point. So how do you push through? Right. I've struggled with this a tremendous amount. I can't even tell you the number of books I've started and got stuck on. So that's very hard. It's very hard. So that's something that never stops, as well. Yeah. So I just wrote down some thoughts. I mean, there's not really random thoughts, but they're all kind of with these themes. One thing I use is some games. Like that's a technique I use sometimes. Like StarCraft, like I've already said, is something I use to get out of my own head. If I ladder StarCraft, that just takes my full attention and I get into this like flow state. And just, it's something kind of like sleep that can reset my mood or my thinking to some extent, and also can give me energy. By the time I'm done crafting, I usually have more energy. And then there's Angband and Tetris. So Angband is this roguelike game. I think it was based on Moria initially. I've been playing this game since, some version of this game since 1989. I've never won it. I've gotten close. It's got randomly generated levels and things like that. And it has tremendous replay value, in my opinion. And that's something I can play, and it, sort of keeps me occupied at some level, but not so occupied that I can't think things. Okay. So, but it keeps me like, I'm not on social media. I'm not looking at the news. I'm not watching a YouTube video. I'm not watching TV or any of those other things. I'm, at the keyboard doing this thing. And it gives me time to think. It gives me a way to think, sort of like an extended shower or walk or something. Like, I can just like do some Angband, and while I'm playing Angband, I'm thinking. Okay, so that's the different thing than StarCraft. I play StarCraft to not think, to think about StarCraft. But when I play Angband, I'm mostly think about other stuff. And Angband's good for like listening to audio. If I wanted to, I could play a YouTube video if I wanted to listen to something and play Angband and then listen to the video like really closely. Whereas if I weren't occupied with something else like Angband, maybe it's my ADHD probably, but I'd probably be on my phone or texting people or something. But so I use Angband for that. And also Tetris. Like if I really want to think, I can just play some Tetris for a while. And Tetris, once again, there's not a whole lot of thinking for me. It's like mostly mechanical, but it sort of like real time and demands things. Angband's turn based, so I can just kind of like pause it and, take as long as I want for each move. But Tetris, that's a real time game, and you have to keep up with it. But at the same time, I don't have to think too much. So anyway, that's one thing that I use, are games sometimes, and other things to get out of my head. StarCraft, lead climbing. Climbing in general, but lead climbing in particular. That's where you're clipping in the rope as you go instead of like top roping. Bouldering also, I think. So, helping someone. That's another thing. It's like often if I'm not in a good mood or if I feel frustrated or whatever, if I help someone out, even with something small, or talk to someone, and, that they come to me for help or advice or something, almost always afterwards, I just feel different, feel better, feel like I can do something. I don't know. I think it's really important to find a small group of people who are going to be supportive of the ideas you come up with and the work you do. Not so supportive that you can throw any slop at them and they'll just forever say, "Oh, this is the greatest thing I've ever seen." I don't mean that, but I mean that they're open-minded and they're going to try to appreciate what you're doing. They're trying to understand what you're trying to do, even when you're like flailing around to communicate it, right? And They're good sounding boards. People you trust who have some degree of taste that is similar to yours. You don't worry about them scooping you if you come up with something great, and that they can provide maybe helpful criticism when you're ready for it, but at the same time they're not shutting it down so much that you don't want to do anything or share it with them. That's hard to find. Even if you can find one person like that, there's a very big difference between finding one person like that and having 0 people like that. And I think if you're getting started in research as an outsider, this can be very hard. Internet maybe makes it easier now. I'm not sure, but it's hard because finding someone who has a similar sense of taste and it's tricky. What I will say is the cool thing about the internet is that people will come to you, right? That's like the big difference, is that if you're putting things out there, someone who sees it, who resonates with you, might reach out to you. And so that's a different mode than, you have to go out and seek someone. I'm not saying you shouldn't seek people, but I'm saying that the ability, for people to find you from anywhere in the world is great. From that perspective, at least. Maybe it's not maybe it's not always great for anyone in the world to be able to find you, but for this purpose, I think that's good. And it often only takes one person whose opinion you trust who says this is great. Like I like this song by LCD Sound System called "Losing My Edge," and I think you could replace all the lyrics with things related to programming languages. James Murphy has this great interview where he talks about failure. James Murphy on failure. You can find it on YouTube. One of the things he said was losing My Edge, which was the song that really made him famous. He didn't decide to lead with that for his album until like the last moment. And, other people were like, yeah. And he said that the reaction to that song from most of his friends was like, oh, that's interesting. Or there were technical things like, oh, it's interesting how you use the drum there. You could tell they hated it. And then he played it for another friend who was older, and it said, I love this. So one person, it only took one person. And, I think that's often the case, and for me, for like the miniKanren stuff outside of the IU group, it was like the Clojure people. It was like David Nolan. That was like one person. And then other people like Ambrose. So we had a couple people, but the fact that David Nolan created Core.Logic and that people were giving talks on it, that sort of thing, like that was enough. That was enough to keep it going. Those were rough times back then in terms of miniKanren interest, let me tell you. So that was great, and I do have a small supportive group of people I show stuff to. And I think in general, if you're doing anything researchy, and once again, I'm not talking about you being a professor, okay, or you being a researcher at a research lab. It has nothing to do with it. It really doesn't have anything to do with it. Just if you're doing something research, if you're doing something where you're trying to create something fundamentally new and rethink what people are doing with like programming, that sort of thing, or rethink how languages should be designed or implemented, I consider that you're doing research. And I think, we have a lot to learn about, learning things and being good at things from like StarCraft people and communicating things and using the internet from StarCraft people. But I also think as researchers, there's an awful lot we can learn from artists and filmmakers and writers and musicians and dancers, anyone doing creative work. Okay. And once again, it never stops. You always want to get better at this. And even if these things, like I'll often go back and watch a an interview or a talk again that I've seen many times. It's like, oh yeah, that's right. Yeah, this is really hard. It's like, that's really hard. That movie that I love was barely made. Almost every movie is barely made. That's one thing I found out. It's like all these movies, it seems great. It's like, oh, those actors hated each other. These actors have such great rapport. No, they couldn't stand each other. They couldn't stand the director. They quit and all this stuff. Yeah. I'd also think, for giving talks, stand-up comedians have a lot of insight. There's a documentary called Dying Laughing that, if you replaced what they're talking about, stand-up comedy, with like giving talks, lots and lots and lots of talks to different audiences, I think it's very similar. You're trying to present these ideas. And some audiences, especially if you're giving talks in different places, academia, general public, giving talks internationally, recording talks on the internet, whatever, that's something that takes a lot of practice, I think. And I remember the first time I gave a talk in Japan, I was like, oh, okay, this is totally different. Or the first time I gave a talk in Poland, it's like, okay, this is different. The what the audience expects is different, or what I can assume is different than when I'm giving a talk, in the United States, or if I'm giving a talk at a, meetup for people who are mostly industry programmers, right? Like the talk I give is going to be different than if I'm giving it to, like at the miniKanren workshop, right? It's just going to be different. So. Stand-up comedians, they have a lot of practice, having to deal with doing something really hard in front of a variety of audiences who are in totally different moods, it turns out. So anyway, I think that's interesting. I think stand-up comedians and giving live talks are very, very similar. There's like hot crowds and cold crowds, and you could tell, like, if there's a hot crowd, man, I could do really well with a hot crowd if I'm in the zone. And if I have a cold crowd, whoa, that's gonna be tough. And then, like in general, use everything you've learned. You use what you've read, use all the classes you've taught, use your experiences at work and volunteering and everything else. My work background was in special education, and I worked at and then ran a special needs summer camp. I was a special ed teacher, middle school, for a couple of years. And then I went into, computer science. I had been a programmer hobbyist for a long time, but that wasn't my background. And I thought, especially when I was going to grad school, I thought, wow, here are the people who are much younger than me, who went straight through school, and they've taken all these extra classes, and, I don't know if I can do this. And, my background seems like special education. Like, why? That seems totally pointless given what I'm doing, right? It doesn't seem to have any connection at all. And it's like, wow, that was wrong. What did I do as a special ed teacher? Well, I would take complicated concepts and try to break them down and explain them in a way to make it easier to understand. And I spent a lot of time trying to understand why people find ideas confusing. What are alternative ways I can explain the ideas? How can I come up with really simple examples that illustrate the techniques? How can I assess where someone is struggling? All those sorts of things. And then it also involved a tremendous amount of speaking in front of live audiences and teaching and stuff like that. So yeah, it turned out all of that was super useful. So whatever your background is, I'm sure there are aspects of that. And in general, I'm interested in these two questions, which I think come up in the series and are going to keep coming up in the series. I mean, I'm interested in more things, but these are two questions that I have a deep and abiding interest in. One is, how do people learn? especially complex skills. Okay, so that's why something like B to GM for StarCraft I find so interesting, that idea and how effective it can be. And the nice thing about studying a game like StarCraft or chess or Go is you can tell where people are at different levels, right? It's like it's there's an objectiveness to it that's easy to measure in a way that, how can you tell if someone is good as a researcher or someone's good as a programmer? I think that's much more nebulous. There have been attempts to try to come up with something like an ELO rating for researchers, like the H index and stuff like that. I think these are all totally misguided. Those are measures of research productivity in terms of number of papers written and things like that. And of course, once you have some metrics like that, people are going to use them for things like promotion and hiring. Totally misguided, in my opinion. I think it's a really serious problem. And some of the greatest researchers in history, if you looked at their H index, would be tiny. Actually, all the papers, if you look at the papers in science that are most cited, let's say, they tend to be, biochemistry technique papers that are widely used in a lab and a zillion people cite. Right? That's what the most cited papers are in science, at least my understanding. It'd be sort of like if every time, you did anything involving a for loop, you cited that. It's like, okay, so-and-so invented the idea of a for loop. And, I imagine the number of computer science papers that would cite the for loop. Well, in biochemistry, they have more of that sort of culture. And anyway, that's got nothing to do with it. And a lot of times you can't tell if someone's research was important or not until, many decades later. And it's like, oh yeah, this is totally important. Anyway. So that's one reason I think watching how people learn StarCraft and teach StarCraft is interesting, because you can measure it in a different way. But you can also look at styles. There's some people like Spanishiwa or Katz that had really interesting play styles, very unique play styles that were fun to watch. And then the other question that I'm very interested in is, how do people make things that they themselves and that other people absolutely love or respond to in a really deep way? So that I think is really interesting, because that's what I want to do. I want to make things that people respond to, that I respond to, right? Like, hey, if someone had shown me this, I'd be like, yeah, that's it. That's the thing for me, right? Like, how do you do that? And for the people who have succeeded in doing that, how do they do it? Especially if they can do it more than once. How do they go about it? So those are things that I never stop trying to learn more about. Okay, so those are themes. Those are themes in my life. This isn't like a part-time thing. This is like, I'm always looking for these. Okay, I'm always looking at this and thinking about it and talking to people about this stuff. A couple books and references and talks and stuff like that I think I found interesting, that are in this vein, so a couple about by or from artists of different sorts. So one there's a book called The Creative Habit, Learn It and Use It for Life by Twyla Tharp. Here's the book. And she's a dancer and choreographer, very creative. And this book is really interesting. I don't know a whole lot about dance, but I think this book is full of gems, and also talks about, like, it opens with one of the reviews she got when she started out as a professional dancer, and wow, is it brutal. And so part of it is like, how do you keep doing this? How do you keep doing it day in and day out, and year in and year out, and decade in and decade out? How do you not give up and do something that's easier where people tell you what it is you're supposed to be doing, where you can tell if you're doing well or not. You know, that is one difference between StarCraft and chess and like research. Is like you could tell if you're making progress, in StarCraft, right? Like, hey, now I've been promoted a league, that type of thing. I'm starting to do well in tournaments. In research, it's much more disconnected. It's like, hey, here's this thing I came up with, and we'll see if anyone ever finds it interesting or useful. Maybe they will, 30 years from now or 50 years from now. And that aspect, I think, makes it harder. So, you can tell where you are with chess or, that sort of thing. Hopefully you see you're improving. But with research, it often feels like you're just, it basically always feels like you're flailing around, like, yeah, this looks interesting. Maybe you can push it, and then you get very excited. But then maybe you can't push it any further using that approach, so it's tricky. Now, I think it's probably similar to every single time you want to get much better at something like StarCraft or chess or Go, you're going to have to start learning new techniques or at a much deeper level, right? And you're going to hit a bunch of learning plateaus probably. So that part's similar. But the fact that even if you did really top-notch research, people might not recognize it for a long time. So in cryptography, Whitfield Diffie basically came up with public key cryptography when he was a grad student, and he wrote a report on it. This was already known by the British cryptographers and I think the NSA, but it wasn't known in the open literature. So as a grad student, he came up with it, and he wrote a report on it for a class, I think at Berkeley, and it did not get good reviews because it was such a novel idea. It was proposing something that was considered impossible at the time, and he didn't know how to communicate it very well because he was just like, oh, well, maybe you could do this. So he said, like, I don't blame the teacher because I didn't write it up very clearly. It's just a hard thing to understand the first time. It's like now, you learn public key cryptography. That's just like a thing that exists. It's like a thing everyone uses. But when it was first discovered and presented and it hadn't been implemented in, any real way and stuff like that, it took a leap of faith to understand that this might be important or this might be real. So anyway, that book I like. There's another book called The War of Art by Stephen Pressfield. This is a pretty famous book. Now, okay, so here is the website for it, stephenpressfield.com. I think the book is worth reading. All right. With any of these books, I think, you take from it what you can, and there'll be things in the book that, aren't for you. Let me put it that way. There's always this tendency in our society that if something has any success, especially if it's of any commercial value, then it becomes like a brand or a franchise or something, right? It's like, get the app and here it is on Oprah, and so this is, well, congratulations for him for selling lots of books, but it, I don't know, this doesn't resonate with me. It reminds me of a Roger Ebert quote when he got some press release about one of the Spider-Man films, Spider-Man 3 or something. And it talked about the franchise, the Spider-Man franchise. His response is, "This is not a film; it's a franchise, right?" Anyway, I don't like the franchisement of this stuff, but I did find it interesting. And once again, this is more about sort of the psychological aspects of things. There's a YouTube channel I like called Film Courage, which is I guess the woman who created that, she interviews a zillion filmmakers, writers, directors, whoever, producers. And a lot of it is, how did you get started? What have you learned? But an awful lot of it is, film courage, right? These aren't film techniques. This is film courage. It's like making films are really, really hard. And so a lot of it is about the psychological aspect and what people had to do. A lot of times, like, when someone became a writer, they would be working in an office job, and they would write during their lunch break every day, that sort of thing. They might have to do that for years, but they wanted to do it, and they found a way to do it, but they had to be courageous to do it, right? I mean, if they could have given up and no one would have noticed other than them. And there's one series of interviews, there's like a whole playlist for it, which is with Dr. Ken Atchity. The first one's Quit Your Day Job and Live Out Your Dreams. That's, he's got a book about that also. But this whole series, this interview with him, which I guess they have the full interview and they cut it into parts. But that's very interesting. So he was an academic. He was actually a professor at Occidental College for like literature. And then he decided, after he got tenure as a professor, that he wanted to go into, film and be a producer and all that, and start his own, publishing company. And he's done that for many years. So he quit this job where sort of like the ultimate job security tenured professor to do something, extremely unlikely to succeed. And all of his professor friends were like, what is wrong with you? So it's interesting just that setup. But I think he has a lot of interesting observations about what he calls type C personalities. Like, there's the type A personality, supposedly, things like that. So he says type C personality, these are people who have the need to create. So he talks a lot about the psychology, and he talks about the importance of things like, if you're working on a project for a long time, when you're finished with it, you are going to get depressed. And that's one reason he thinks that a lot of creative people have issues with depression. He says, the trick to that is to start another project before you finish the current one. That's the remedy. So it's interesting to see the different creative people, different people working. I shouldn't say creative people. Everyone's creative. It's just whether or not they're using it to their full power. But I find it interesting to see how different people approach things psychologically, and in particular, how they deal with issues of depression or feeling despondent that your work is worthless, or all these sorts of things. It's that's just a real thing. I mean, it happens. There's no way around it if you're in this business, as far as I can tell. And then here's a book that I read that I just found was really interesting. So, like I said, I find it really interesting. Like, how do things that people respond to, or that I respond to, how is that created? And so here's this book, Blood, Sweat, and Chrome, The Wild and True Story of Mad Max Fury Road by Kyle Buchanan. I watched Mad Max Fury Road in the theater, and at the end of it, I was like, what in the world did I just see? I couldn't even process it. I had to watch it again to see if I liked it or hated it or what. I don't know. I couldn't even conceive of what I had seen. And then I decided I loved it. But the making of this movie, talk about a movie that should never have been made. It was like almost impossible to make, and it was canceled. And, the full timeline of making this movie spanned decades. Anyway, it's a super interesting read, and it's also interesting to see kind of the dynamics between the people involved, and Yeah. So this is the sort of thing, or like the movie Aliens, James Cameron's Aliens. That's one of my favorite movies. That movie, you know, was barely made in many, many ways. Right. So that actually reminds me a little of the summer camp. Like when I was running the summer camp or working at the summer camp, there were always things going wrong. Every day something went wrong, and every week something pretty big would go wrong, and every session something really big would go wrong, and you had to just figure out a way to keep it going. So that reminds me a lot of research projects also. So anyway, I find this interesting. I'm also right now reading a book on Star Trek Phase 2, which was supposed to be a continuation of Star Trek after Star Trek went off the air. And it never ended up being made. Instead, the Star Trek movie, the motion picture, was made. And then Next Generation, ended up getting some of the sets and things like that. And I was starting to watch the Star Trek Next Generation again. And the first season is famously quite bad. some really horrible episodes. But one of the things I noticed was from the first few episodes, like, okay, I remember reading, like watching later seasons of Star Trek Next Generation, and it had its own look. But the first few episodes, season 1, it looks like classic Star Trek. It looks like they took sets from the original series. And I think it's because of like this Phase 2 thing. I mean, they had scripts, ready. Some of the scripts got repurposed into Next Generation. So Next Generation, the beginning of it really was more like Star Trek Phase 2 repurposed. And then over time, the show got its own feeling. But that's also really interesting. Like, people respond to Star Trek. How was Star Trek made? I've read a fair amount about the making of Star Trek and things like that. So yeah, that's an interesting book to me. And then there's Werner Herzog's Rogue Film School. And here's the website for it, which is amazing. Oh man, I love this. These 12 points. This is worth reading. Okay. About the Rogue Film School. Here's number 4. The Rogue Film School will not teach anything technical related to filmmaking. For this purpose, please enroll at your local film school. See? This is what I'm talking about. Okay? It's the same with filmmaking. Okay? It's the same in art as it is with research, right? There's the technical part, and you need to know what Lambda is. You need to know some programming and type theory and stuff like that if you want to do like programming language stuff. But that's not what makes the research really hard. Not at all. That's really not what makes it hard. It's everything else is what makes it really hard. The Rogue Film School is about a way of life. It is about a climate, the excitement that makes film possible. It will be about poetry, film, music, images, and literature. Okay, so this is a film school. He's talking about poetry. He's talking about literature, right? Yeah. Let's see. Related but more practical subjects will be the art of lockpicking, the exhilaration of being shot at unsuccessfully, the creation of your own shooting permits, the neutralization of bureaucracy, guerrilla tactics, self-reliance. Okay. This is my favorite. 9, censorship will be enforced. There will be no talk of shamans, of yoga classes, nutritional values, herbal teas, discovering your boundaries, and inner growth. Yeah. I almost led this with, the series with something similar. Like there'll be no discussion of Bitcoin or blockchain or, full stack development or whatever. Agile. Yeah, and then here's a reading list. Okay, this is for filmmaking. Virgil, Hemingway. And then Baker's The Peregrine, which is a book I haven't read, but I need to read this. And then Film List. Okay. And then number 12, follow your vision. Your vision. Do you have a vision? I have a vision. Form secretive rogue cells everywhere. At the same time, be not afraid of solitude. Okay. This is probably the most important part of being a researcher, in my mind. Number 12. That's it. That's it. This is it, but that's the hard part. Yeah. As far as the book The Peregrine that Herzog talks about, he gave, there was this interview in Stanford with Robert Pogue Harrison, was interviewing him. Or they were talking together, I guess, about books and literature, right? So here's a filmmaker, someone known primarily as a filmmaker, but also he's a writer. And he's talking about the influence of these books on him. And one book he talks about is called The Peregrine. And so at 28 minutes in, he's talking about it. And in the foreword to the book, apparently, it says, this is not a book about peregrines. This is a book about becoming a peregrine. So it's a book about this type of bird, which I think is the fastest animal on the planet when it's in a dive. And Herzog just loves this book. And the book has been criticized by some ornithologists as not being accurate, containing some inaccuracies. And Herzog's response is great. And he says it's the same response as he tells people, about film. People are criticizing his film. And to me, this feels like this really resonates when you're trying to do something like reinvent how you look at programming. Okay, reinvent something like that where it's already practical. There are practical approaches, but you think there's a totally different way of doing it. And that in the short term, it's going to be far worse. Whatever you do with this new approach is going to be far worse, and you're not going to be able to do even basic things that even a beginner could do using the standard approaches, right? It's like now it's a research problem. So when an ornithologist tells him that the book has inaccuracies about the actual behavior of peregrines, his quote was, "It's the accountant's truth you're after. You get a straight A, you idiot." You have to play the video to listen to him saying it in his voice. It's very funny. But the accountant's truth, right? It's like, that's often how I feel when someone is critiquing a new research idea. It's the accountant's truth you're after. And also, like you get a straight A, right? That's like the undergraduate thinking I was talking about. It's like, okay, congratulations. Yes, you found you found like a technical thing that might be wrong, but you also like missed the entire purpose of it, right? The purpose wasn't to say the book contains an inaccuracy, so dismiss the whole thing. That's not the point of the book at all. To Herzog, at least. And he says, yes, go become an accountant. That's where you should be. An accountant. And then he also says, the ornithologist should be denied to read this book. Right? It's like, it's sort of like the rides in an amusement park. You have to be this tall to ride it. It's like your spirit has to be this great to even attempt programming in this language. It's, or this approach, right? It's like, you have to be willing to tolerate uncertainty and to have imagination and to think, what happens if this is pushed really hard for 50 years? What could happen? So, that resonates with me. And, I think someone like Herzog, who does have vision of what he wants, he's constantly encountering people, especially if he's trying to produce a film or something, who don't share that vision or have no interest in it or whatever. That's no different than being a researcher. Or when I say, once again, when I say being a researcher, I mean having original ideas and trying to push those ideas as far as they can and communicate those ideas, right? You're going to always run into people who are the accountants. When I gave that talk, The Most Beautiful Program Ever Written, on YouTube, you could see the comments initially. Initially, there were comments on that video. They've been turned off. I didn't turn them off, but they were turned off. Initially, the comments were all from people interested in functional programming or Scheme or whatever it was. And they were universally positive. Like, people really liked it. And then at some point, the YouTube algorithm, maybe because there's lots of engagement or whatever, started showing the talk to other people. Like started promoting it. And you could see the comments change. You could see them change, right? In fact, you could see the exact day, probably the hour at which the YouTube algorithm, promoted the video. And the comments were not kind. Let's just put it that way. There was some dude in Australia, man, you would have thought I would have run over his dog. He was so angry. He's like, this is what's wrong with academia. And, academics like wasting our time. This guy's never built anything. He's like, yeah, dude, I came from industry. I built plenty of things. But yeah, like that was what I wanted to say to him. This is the accountant's truth you're after, right? Go become an accountant. That's what you should be. Anyway. Wow, is he mad? He left multiple comments. Here we go. Quentin Tarantino and Terry Gilliam on having a vision. That's another video that I found. Tarantino has told this story multiple times. Now, Tarantino, polarizing person, polarizing movies. The movies are not for everyone. Some people hate the movies. But you have to say that he has a vision. There is a Tarantino movie and style, like it or not, he's got his own thing. And he's talking about when he wrote the script for Reservoir Dogs, he, I think, got into Sundance, and he was assigned Terry Gilliam, the famous director of movies like Brazil, to mentor him. And Terry Gilliam is known of having this vision in his films. You can always tell a Terry Gilliam film. And Quentin was asking him, how do you realize that creative vision, right? How do you conjure that into existence? And Terry Gilliam said, Quentin, you don't conjure it into existence. You don't have to do that. That's not the job of a director. What your job is to do is to have a vision and to communicate that vision clearly to really good people that you hire who can do the job, who can do the wardrobe, who can do the sound design or, the set design, all those things. You need to have a vision that you can communicate clearly, and you need to hire the right people, and they will execute on your vision. And he said that was, some of the most profound advice he ever got. And I think that's this idea of having a vision is really important. For me personally, that's the way I think about it. Now, not everyone who does research, cares about having a vision or has a vision. There are other approaches to doing research. So there are other approaches, and also what people call research is very different. So in industry, there's this research and development, R&D. Sometimes you see R&D in government. A lot of times the R in R&D is not what I would call not what I would call research. So it's not like we're going to try to reinvent how programming is done. It's more like, well, here's a thing we've decided on, and there are like a couple minor technical problems, so we got to fill in or something like that, or we need to develop a new standard. Okay, it's research at that level. So what people call research is different. But even a lot of researchers, say in academia, doing original research, and I know quite a few researchers in this, who use this approach. They're looking for problems that are well suited for their techniques that they know and their background and knowledge and their taste in problems. And so, they'll look for what they call low-hanging fruit problems. Like, oh, here's an open problem, and the person who posed the problem doesn't know this technique I know, so I will work on the problem and write up a paper and whatever. And they have a very successful career, doing that. Okay, and I have no complaints about that because I think most science is incremental in nature. Having said that, I think there's tremendous power in having a vision. Okay, and once again, I don't think it's for everyone. I think this is something you develop over time, and it requires a certain taste, and it's like a certain need to say, hey, the truth is I'm disgusted at how programming is done. I always have been. I've been disgusted since the first time I wrote a program. Like I thought the whole thing was disgusting. Full stack development, Java development, web development, it's all disgusting to me. I really dislike it. I always have. Because I think there's so much mismatch between the level at which I want to operate and think about and describe things versus what you actually have to do, and all of the inessentialness, low levelness that aren't important. I resented having to use Java as a language that was largely designed to appeal to C++ programmers, right? There was like this marketing aspect of it, and it affected language design as far as I could tell. Or that they didn't want any one programmer to have too much leverage, so they didn't add macros, even though Java was mostly designed by a Lisp programmer. Stuff like that, It's like, oh, disgusting. So anyway, I have a vision based on my disgust for programming and my long experience with it, and looking around hard for a long time at what people have done, those sorts of things. And, going to grad school and studying under Dan Friedman and working with Dan and Oleg on miniKanren and writing a book and interacting with a bunch of other people. And, that's why I went to grad school, right? Was to figure out like, hey, is there a different way to do this? Because I don't really like it, even though I like programming. I didn't like the way it's done. So, but someone like Terry Gilliam has a vision, when making a film. So I am of the vision type, I guess I would say. Okay, to me, like that's part of that's like the artistic part. Okay, this is one reason I'm inspired by artists and filmmakers, as much as by mathematicians or physicists or computer scientists, is that the vision part I think is really important to me. Okay, I wouldn't be satisfied having a career just doing like incremental, low-hanging fruit things. That's just like a personal thing. That's probably like a personality thing. Having a vision is tough, and going after that vision and trying to keep it for a long time is tough, but there's also, compensation, which is you don't have to do it all on your own any more than, if you're a filmmaker, you have to do every single thing by yourself, unless you're Robert Rodriguez, and then you do everything by yourself, with his early films. That's actually, another thing is Rebel Without a Crew, a book by Robert Rodriguez about the making of El Mariachi, where he basically did everything except star in the film. That is a very interesting read. So having a vision has advantages if you can communicate that vision. If the vision is compelling and you can communicate that vision to other people clearly, then I think there's a lot of power to it, and you can do things. And I mean, if it's a compelling vision and you can communicate it clearly and you're willing to work on it for a long period of time, even when, no one else seems to care, then you at least have a chance. And with the internet in particular, there's a chance that other people who share that vision, or they think that's a compelling vision, that they will be attracted to it and they'll want to work with you on it. Or maybe they'll have their own take on it. Maybe they'll riff on it. And they'll say, okay, I think you've got like kind of the right idea, but I think it should be done this way. Okay. Anyway, I think that's super powerful. And so this is why for people who can only work that way, like I can only work this way. I can't be at my best. I can't do my best work if I don't work in this way. I can work. Most of the time I'm working, it's not in this way, but longer term, I think the things that I do that are really of value, there's a vision component to it, and it includes making this series. Okay. I am very, how should I say it, not pleased with the resources available for people to learn, how to do research in academic PL or to learn the techniques or whatever it is, I have a vision for that as well. Now, it doesn't mean I'm going to be successful in executing on the vision, but I do have a vision for it, and I keep trying to, flail away at it, and who knows? Maybe eventually I'll figure out something that works. So I think there is tremendous power in having a vision and being able to communicate it clearly. Now, the other part about having a vision is, what if you don't have many resources, right? Like, I'm not a billionaire. I can't just try to hire the best computer scientists and get them to work on my problem, or, I've never had any money to fund miniKanren research. So, well, what do? You don't have a budget, and, you can't hire people. So what can you do? Well, the power of having a vision that's compelling to at least some people, and plus the internet, plus if you can communicate it all clearly, people will find you. That's the thing, right? People will find you, and it only has to be 1/10 of 1% or 1/100th of 1% of the people who find it compelling will come find you. That's the power of it. Okay, the internet makes this possible. Without the internet, what could you do? Well, go to elite universities and give talks and become a professor at a fancy place and, whatever. I mean, there were some ways you could do it, but even then your audience was generally going to be much smaller. So, putting out your vision as clearly as possible. And then this is where the repetition comes in, right? Like Vibe saying that, he felt like a broken record, right? It's like, well, if you have a vision and you want to communicate it, guess what? You can't say it once and then hope that the world responds to it. It's like the Howard Aiken quote, or the Howard Aiken story. It was a famous hardware designer at early computer pioneer at Harvard, and the story was that he went to some graduation party from a student who had just finished his PhD, I guess. And the student had copies of his dissertation, but they were all stamped like confidential, do not redistribute or whatever. And Howard Aiken saw it, and apparently he just shook his head, said, "Son, don't worry about people stealing your ideas. If they're any good, you'll have to shove them down their throats." That's been my experience. It's like, if you actually have like a visionary idea of how something that people are totally used to should be done totally differently, the problem isn't that they're going to steal your idea. The problem is getting anyone to pay attention to it at all is hard. Now, there may be some point at which the idea becomes adopted, and then, will big tech just take it and, patent everything and lock it up and, sell a subscription to it and who knows what. Okay, so that is a real thing, and that is something I think to be concerned about. But that comes much further down the line, than the vision part. So that's the decades later when the idea actually becomes something of financial import. As soon as something becomes financially important, people are going to scramble around, try to grab it or grab a piece of it. But that, having a vision is a very different thing, and then trying to communicate that. And most of the time people have a vision, try to communicate it, and nothing happens. No one cares. No one responds. Or the person has a vision, then they have another vision, 2 weeks later, or they give up on it or whatever. It's really hard to do this long term. So that's why having a vision is important, because it helps you, align your research and your work and your communication. And if there's something you really care about, then you're going to want to keep talking about it, right? So I love Scheme. I love miniKanren. That's why I keep talking about it. That's why I keep trying to write books, even if not very successfully. So I keep trying to make videos and figuring out how to communicate that. It's I do want other people to see the beauty in it, and also to help push it further. So anyway, that's the thing, right? Do you get out of bed in the morning? It's hey, let's make some progress on that. So I think personally that's also very fulfilling. Okay, but it also takes a lot of, it's also more nebulous, right? It's more nebulous than low-hanging fruit and look, I got another publication, right? My H-index has increased or whatever. It's a more nebulous thing. How do you know if you've succeeded in, advancing the vision? I don't know. You have to decide what that means. But it's something you can keep working for, right? Advibe says, it never ends. It keeps going. You keep trying to do better, keep trying to refine the vision, see the vision go in different directions, and find better ways to communicate it. Other people will riff on it. They have their own version of the vision. They have their own vision. They mix together, right? But that's very powerful, I guess, is my point. And artists who have a vision, that's something people will reply to or respond to, in any medium. And then there's also tremendous power, I think, in having an artifact. That's another thing I've learned, is that, there are a lot of academics or a lot of researchers who write papers on something. Maybe it's an idea, maybe it's an algorithm, maybe it's an approach or technique. Okay, that's all fine, and maybe those are really useful. If you have an artifact that you can work on for a long period of time, like Shea Scheme or Dr. Racket, to pick two examples, or Chow Prologue, then there's a way to kind of organize your work around the artifact. And if the artifact's around for a long time and keeps growing or improving in different ways, then people can interact with that artifact. I think there's a lot of power in that. There's a power of, people sort of gravitating around this artifact and using it and wanting to improve it or playing around with it different ways. It's something, it's rich in projects for people to work on, rich in experiments. So I think having an artifact's very powerful. It's another thing I think I've learned. With miniKanren, we have an artifact, faster miniKanren, which is a faster version. We have Barlaman. But in terms of, what people have responded to on their own, it's more like the microKanren. The microKanren, Jason Heeman and Dan Friedman's microKanren. People love that because they can implement their own, logic programming system in 50 lines of scheme. And then, do it in whatever language they want. That's like become a standard exercise. So I think that is extremely powerful, right? Yeah. So anyway, those are just thoughts I have. Yeah. So I guess the type C personality is actually you would call it. I think that's tied to the vision part. Are you happy to just find low-hanging fruit problems that you have a set of techniques you can apply to and kind of turn the crank? And nothing wrong with that. Okay, the world works on that, and a lot of research is based on that. It's really, really important. We couldn't function in a technological civilization without that. Okay, I'm not disparaging that at all. I'm not trying to. I hope it doesn't come across that way. However, there's some people who have a vision for how things could be. And this is different. This is not turning the crank. This is not, I've got a bag of techniques, just apply it. There's something bigger in scope for that. So, I think part of what's important is understanding what you want to do, and like what is your personality like? What is your what appeals to you? What are you good at? What do you want to become good at? Being able to communicate clearly, that's tough. That's a skill. Is a skill you can learn. It's a skill you can improve on. Yeah. So do you have a vision? I'm not saying you should go off and say, I have got a vision because I want to have a vision. Like a vision is something that, you develop over a long period of time with lots of experience, probably based on some frustration and some things you love and stuff like that, right? So, getting to the point where you even have a vision is hard. And a lot of people never get to that point, or maybe they kind of have a vision, but they never commit to it, right? Anyway, that's like the paraphrasing effect, I guess, is the vision part. But I definitely have a vision of programming and how it can be done. That's different than how it currently is. Okay, so anyway, this is a bunch of high-level stuff. This is like macro-level thoughts, right? This is all about the psychological part of doing research or having new ideas, thinking about things. But even I don't know if I sound like a broken record, like Vibe was afraid he was sounding like a broken record. But I guess my point is, it's the psychological, emotional, parts of research that I actually think is much, much harder, because if you're working on hard problems, and certainly if you have a vision you're trying to realize, like this is something that takes a long time. Okay. You're talking months, years, decades, maybe. You're not talking, hours, days, weeks. You can make some progress in hours, days, weeks, but, the vision, the power of having a vision is, first of all, you can get other people to work with you, right? If they find it compelling. And also if it gives you some idea of, like, if no one finds it compelling, then no one wants to work with you. Well, maybe you should reconsider the vision, or, clarify your explanation. And in fact, the cool thing about the relational programming is a number of people over decades have had ideas of doing relational programming, like general purpose relational programming. This is not a new idea. This certainly traces back, I think, to at least the late 60s. This is the first time I saw any reference to this, idea. So when I say I have a vision, I have a particular variant of it maybe that I have in mind, but that's not a new desire to do relational programming. That's an old idea. As are most interesting ideas, are usually old ideas. But the cool thing is, if you are someone who shares in that vision, or someone who wants to have something like relational programming, and you make it clear that you want that to happen and you share your work on it, then other people who are also think that's cool will find you and they'll want to work with you, right? So you don't have to be a billionaire and you don't have to pay people, right? Like, you'll find the other weirdos who share that vision will come find you and say, hey, I want to work with you. And then you'll figure it out somehow. Okay. That's the nice thing about having a small group of people who are highly motivated to do this thing. It's like, well, we can all have day jobs and still try to make progress on this thing. So that's once again, the power of the internet. Yeah. So, I guess something worth thinking about yourself is, do you have some vision, or have you had visions of things you want to make, to realize in terms of programming or other aspects, other creative aspects? Or, are you much happier doing kind of the low-hanging fruit? So low-hanging fruit, applying a known technique to a low-hanging fruit, I think that's, that still is research. You're still solving problems where the solution is often not known. It's not known if that technique will work or whatever. So I'm not saying that's not, legitimate research. It certainly is. It is a different degree of nebulous, I guess I'll say, right? The vision thing is much more nebulous. And so it's up to you to have a clear enough vision and to be able to communicate that clearly, usually multiple times, probably over an extended period of time, and refine it and react to other people's work and their vision and input. So that's a different level of thing. So I think it's worth thinking about, kind of how you think about this. Okay. I do think that learning a bunch of techniques, that's, the skill that you can learn, just like learning, pylons and probes and, spreading creep and all that. You can practice it and get it better. The vision part, I think that's why it's important to read widely and, find things you love. Watch great movies or movies that you find are great. They could be B movies to other people, but something that you respond to. Just find things you respond to. Have develop your taste. All those sorts of things, right? Like if you can't tell if you think something's good, then how in the world can you tell if anything you make is good? Now there is an idea that for an artist, like it's not your job to assess your own work. And I do understand this approach that your job is to put the work out there and let the world respond to it. And I understand that, and I definitely agree to that with some to some extent. At the same time, if you really don't have any sense yourself of what you like or don't like, what are the odds that you're going to produce something that other people really respond to? I don't know. Doesn't seem very strong, right? Like the things like the programming languages I respond to, those were designed by people who have some pretty strong feelings and ideas about how languages should be made or what they liked and what they didn't like, right? So if you don't have a strong taste in the area you're working in, the fact like the possibility you're going to create something really amazing to at least some people, I think not that great. That's my guess. Okay. But I suspect it's right. Anyway, that was all the high level psychological stuff I want to talk about for now. But like vibe, I feel like I'm a little bit of a broken record talking about this stuff, but I think that this is at the essence. Okay. I think this is at the essence of doing original research, communicating it is, and then we have this low level stuff like quasi-quote. Now, before we get into quasi-quote, let's see. There were some comments on YouTube and also in Discord. So one comment on YouTube, when I was talking about the types in Java for like integers, the comment was that long is really a 64-bit in Java. So I got confused by that because it seemed to be 32-bit. But you need to specify that the literal is a long value by adding a suffix. Okay, this is from EMSZP. So 1000L instead of just 1000. Okay, so you have to put a capital L at the end of your constant or your literal to make it treated as a long value. And then there's some going back and forth between 64-bit and 32 bits. And yeah, also another type, which I didn't mention, was the byte type, because I was talking about the different types of integers. So char is an integer type in the sense, but so is byte. Okay, so we had shorts and longs and ints and all that, but there's also byte. So yeah, I missed one because I thought there were at least 7. And then the comment says there are also boxed versions of these. Okay, so maybe those are different types. I'm not sure. And don't let me get started on the floating point. On floating point arithmetic, it's all a huge mess. So I agree with that. So anyway, I thought that was interesting. And I did look up online some stuff about like if you wanted to deal with unsigned ints that are long in Java, so I guess Java 8 or Java 9 released some changes for supporting these things. There's some tricks you can use, some encoding tricks you can use for representing unsigned integers, where you end up actually treating them as signed longs. I mean, they're basically represented as signed longs, or it looked horrible to me from reading about it. It looked like, okay, there's some idioms you can use to try to get around some of the restrictions, but it looked like the definition of low-level programming to me, where it seemed kind of irrelevant. But I also understand the desire to not do things like change the Java virtual machine, right? So backwards compatibility and stuff like that. So I appreciate that they probably can't just go and mess with the JVM. But it did seem completely disgusting. And also pointed out that someone pointed out to me, I'm sorry, I forgot who said some of these things, that Java does have a REPL. There's like something called JShell. Now, that's in the Oracle version of Java, and I think the open source versions now have a shell. I don't completely understand how well that's specified in Java. I looked up some of the documentation, and also it just seemed like a real pain to use. So there is a REPL. The Oracle documentation said something like, it's for learning Java and for maybe doing like a little experimentation. But it didn't seem like it was something where you could do real development in. Maybe you technically could, but it seemed really awkward, especially by, with the types and stuff. It didn't really feel like a language. I mean, it wasn't. It was not a language that was designed with a REPL. It feels kind of bolted on. So, but there is a REPL, so JShell, so you could check it out. So, you could check out JShell. You can try using it. If you know Java, play around with JShell, see what you think about it if you haven't used it before. Even if you have used it, go read the documentation. It's like, well, how does that feel compared to other languages that you've used that have a REPL? And then also someone pointed out you can use rainbow delimiters. So you can use, parens. There's like a rainbow delimiter mode for Emacs where the different pairs of parens have different colors. Okay, so that's a mode you can enable. I think you have to download a package for that. I've seen people who use that. I think I may have even tried it once, and I personally found it kind of distracting. I don't know. It was a little too much for me, but that's something worth knowing about. Rainbow delimiters for Emacs. You might find that really useful. Some people do. Yeah. And then another comment from someone who will remain anonymous was that, when I'm talking about things like writing papers in this series, the person who was talking to me about this said that, they normally try to keep anonymous on the internet, or not, they don't want to have a big presence on the internet, which I could totally understand. And things like writing papers and, having their names on things, that wasn't something that they particularly liked. And they were wondering about the series or like what that would mean for things like writing papers. And, my view once again is, if you want to write a paper, great. I'm going to talk about writing papers and reading papers, those sorts of things. If you never write a paper, that's okay. That's fine. It's no problem. I think if you want to get really good at things like scheme programming or relational programming, you're going to want to read papers at least, okay? And you're going to want to, ideally, if you want to go to the next level, you're going to want to communicate with people. That could be an anonymous blog. That could be just in-person conversations. It could be whatever you want. It doesn't have to be publishing a paper. And, I think most things can be done anonymously. If you don't want to write a paper, that's no problem. Certainly, there's nothing I'm going to do will require you to write a paper. I might give some exercises, some ladder practice that are paper related. You just skip that if you don't want to do it. And, anything that would remove your anonymity that you don't feel comfortable with, don't do that either, I'd say, right? If you want to write a paper, like a formal academic paper, and remain anonymous, I think that's a little trickier. There is, I think, some precedent in maybe the security community of people using pseudonyms and stuff like that. For academic PL, I don't know that I've seen papers in the major conferences that are anonymous. That is a debate that's going on. I still see about whether or not people should be able to be anonymous authors on papers. But in any case, there's I think you could do the Bourbaki approach and, use a pseudonym and put things up on the internet in various ways. Now, making sure that people can't trace you on the internet, that's a different thing. That's hard. And now even things like printers in the US, if you print something out with a printer, they're like little micro dots, that certainly for color printers that say things about the printer, right? So it's hard to be anonymous for real. But in any case, don't do anything that you don't feel comfortable with, of course. See if there's anything else. Yeah, I think that's it for those things. Okay. Well, thank you for those comments. And, we got a few people talking on Discord, a few people leaving comments. It doesn't, once again, even one comment from my standpoint, one comment expressing that someone's interested in hearing more about it, that's motivating for me. So, like I said, find a small group of people who find what you're doing interesting, and they'll support you. You don't need a lot of people. It could be one person. Okay. So, we're going to talk about quasi-quote a little bit more. And we also have some ladder practice, right? So for the macro for the ladder practice, okay, so what do we want to do? So for the macro practice, what I'd like you to do is to read or watch, any of these things that I was talking about. Or if there's something else, that you want to read or watch about, living the creative life and making things people respond to. If there's a movie or TV show or something else like a work of art that you really respond to, try to find out how it was made and what the process was, and what were the ups and downs of it, and can you find maybe an interview with the person who made it, those sorts of things. And watching watching a documentary about the making of Aliens, Sigourney Weaver really kept that production from shutting down. That was really tough, and I think that's probably more often the case for something like a movie. It's a big budget film. It's like, I know Chris Gore, who does Film Threat, he said on his YouTube channel that in his mind, he's very into independent film. So his view is that, if you have a huge budget, there's no excuse for you as a filmmaker to make something that's not awesome. And maybe I misunderstand him, but in my mind, that's got nothing to do with it. In fact, it's probably much harder to make something that's a really big budget. Because if you're someone with a vision, just like watch, David Lynch's Dune, right? And I don't know if you're familiar with that, but okay, that's what you'd read about is David Lynch and the Dune movie that came out in the 80s, or it's the only movie I've been to where I was handed a glossary before the movie. I was like, oh, right. This is like what happens when a visionary director runs into Dino De Laurentiis. It's the producer. I think it's very hard, actually, to maintain a vision with all the other things going on and all the accountants and all that. And the bigger the budget, the more the pressure. So, that at that level, I don't agree at all. I think it's going to be hard at any scale, and at some level, having being resource constrained means it's probably easier to focus on your vision without having a bunch of people mess with it. I don't think it's either easy in either case, but that's another one you could read about Dune, or things like Jodorowsky's Dune, that documentary. Anyway, whatever you respond to. I love like 80s films and stuff like that, so that's one thing I love. Science fiction. I read a lot about science fiction authors. A lot of these people, let's just say a mixed bag when you read about what ended up happening, or about some of their personal life details. Is like, it's often a mixed bag. Some people seem, just like universally nice, but even they had their ups and downs, right? Anyway, that's my suggestion. Okay, part of this doesn't end; it keeps going. Right? Like Vibe would say, if we want to do the creative thing, okay, so this is different from like learning Scheme or learning miniKanren. This is, in the same way the paragren isn't about paragrams, it's about becoming a paragren, right? It's like, okay, here, well, if you want to, invent a new paradigm of programming or revisit a paradigm that was abandoned, or something like that, we're talking about that. We're not talking about like how to cons or how to use quasi-quote. Although even with quasi-quote, like I said, there's a whole mini game there. And the idea of quasi-quote and the idea of quotation has been explored in a bunch of different ways, like 3-Lisp. The 3-Lisp language has a idea of quotation that is different than it is in Scheme. Brian Cantwell Smith. So quotation and quasi-quotation, deeply connected to philosophy, logic, philosophy of language, things like that. These operators might look very simple, but they actually have tremendous depth. Same with continuations. Continuations have connections to natural languages. Anyway, so read something, watch something inspiring, and things that can hopefully help you and inspire you to do things that are hard over a long period of time that require a sustained vision. Well, okay. So micro, we're going to do some quasi-quote. All right. So we're going to use two resources for quasi-quote here. So one is the Scheme Programming Language, 4th edition, TSPL4 by Kent Divig. We're going to look up quasi-quote here. You can also look up in R6RS, but right now I'm just going to do TSPL. This is usually the first place I would look. I would look up in the spec, in the report, the scheme report later, after looking at Kent's book first. And, Kent was like the editor-in-chief of R6RS, so, what's in this book is probably going to be pretty close to what's in R6. Now, less so for the Shea Scheme User's Guide, but the Shea Scheme User's Guide also cross-links to this book. So this is like a really good resource. Oh, actually, I did have R6. Okay, so maybe we'll look at R6 also. And then here's a paper. Okay, actually, so this is going to be part of our micro practice. Okay. You read Quasi-Quotation in Lisp by Alan Baldwin. Alan Baldwin. Okay. So this is a classic book, and you'll see that Kent's book refers to, a classic paper. You'll see that Kent's, the Scheme Programming Languages refers to this paper, and probably R6RS refers to this. This is like a famous paper about quasi-quotation in Lisp by Alan Baldwin. Has a long history of association with Lisp. And so this talks about quasi-quotation, not just in Lisp, but also like the idea in C, that sort of thing. And, Scheme, Common Lisp, all that. And here we go. I have two goals in this paper. First, I wish to simply introduce the reader to quasi-quotation and to record some of its history. Second, I wish to draw attention to the underappreciated synergy between quasi-quotation and Lisp's S-expression data structure. And in particular, once we get into pattern matching, you'll see that quasi-quotation, S-expressions, and pattern matching work really nicely together. Okay, so, and here, this is going to be, this paper primarily talks about Common Lisp and Scheme. I will write in Scheme, although what I write will often run correctly in many other Lisp dialects. Okay, so we got Scheme code. Okay, we start with some C code, but the rest is Scheme. And the paper is pretty short. It's like 9 pages long. Okay, so, but it includes an expansion algorithm for quasi-quotation. And so this is something that people have implemented, like how do you deal with quasi-quote? How do you expand quasi-quote? People will refer to this paper. So, Brian Cantwell Smith, it's like, look at the acknowledgments here. Gerald J. Sussman, Guy Steele. Okay, so Guy Steele and Gerald J. Sussman, those are the creators of Scheme. Brian Cantwell Smith, that's the three Lisp. Anyway, there are a bunch of other well-known names here. Some of these people I know, some I know by reputation. Anyway, interesting paper. And one of the cool things is it talks about some of the idioms that come up. So it turns out that that you can play some interesting encoding games with the quasi quotes and the unquotes, because you can nest these things. Okay, so that's where it starts getting more interesting. But this paper is a good good overview of quasi quotation, and talks about some of the neat features of it. Now let me just show you something here I think is worth knowing. In the standard typesetting for LaTeX, I'm sure this paper was written in LaTeX. Here's like the typewriter font, TT font or whatever. Okay, so the unquote, like we looked at last time, that's going to be represented as a comma, right? Comma X. But here we now have two types of quotes. So we have the regular quote, and then we have the quasi quote, or the back quote. This is actually a back quote, the thing all the way on the left. That's what a back quote looks like. It looks like kind of the upside down version of the quote. So this is a quote, and this is a quasi quote or back quote. On the keyboard, or like when I'm typing in Emacs, it looks different. So let me start up Emacs. So if I were to write that expression, let me write this expression. Okay. See if I can put those both on the screen at the same time. So you can see it in Emacs and you can see it in the paper. Okay, so in Emacs you can clearly see the back quote, why it's called back quote, right? Like it's at this angle, or quasi quote. And then here's the quote character is upright. The quasi quote character is at this angle. Also, the quote character, at least with the font I use, is like bolder in a way. It's like thicker. Okay, but if you read papers in LaTeX that use this typewriter font, the standard typewriter font, just be aware that the quote symbol and the quasi-quote symbol, they look the same. It's just like one's flipped upside down. Okay, just be aware that that's what the quasi-quote looks like. Yeah, now unquote's just comma, so that's fine. But that I don't like. I think it's kind of hard to read. And if you're doing a lot of quasi-quote and quote, I think this doesn't look that good. In fact, so for the second edition of the Reason Schemer, we even introduced some typesetting magic to avoid that. So anyway, this is what I would like you to attempt to read. Now, the nice thing about this paper is it is, it's aimed at programmers, but it's aimed for people maybe not coming from so much of a Lisp background, and it, starting off with a C analogy at least. So, it does use a little bit of scheme. So here's like a do loop and scheme and all that. But things like list, we knew. Okay, so there's some things like greater than, equal. If you don't know the syntax for do, you don't know what do is. Well, how would you find it out? Well, look it up. Look up do in the Scheme programming language. Look it up in the R6RS. Whatever. It's not that complicated. You just have to learn the syntax. But the idea, if you've done any programming, you almost certainly can understand the idea of a do loop. It's just the syntax is a little different. And then in Scheme, there's these things called vectors, which are like arrays. And you can change the elements of an array using vector-setbang. So it takes the array name, an index, and then the value. So this is like initializing an array. So this is like a little loop that initializes an array. Okay, so the array has array size. So here, the idea is like, I guess, the array size, we want to make this code work for any array size, any array name, any initial value. So we're going to abstract over those, I think is the idea here. Anyway, or we want to evaluate, these are expressions we want to evaluate instead of constants. I think that's the point. So you can see kind of how you could build up using list, calls to list, and then the same thing using quasi-quote with the unquotes. So this is showing a nice little example there. The syntax of the do loop doesn't matter so much, but use an excuse to look things up, right? So this is this is us, not getting stuck. This is us using our ability to do things like look up things in the Shea scheme programming language or the R6RS report. Okay. So, let's just look at do. So here we go. Scheme programming language. Let's go to index. There we go. There's summary of forms, formal syntax, but I usually just go to the index. So let's go to do. Whoops. Okay, here we go. Do. All right, here you go. Syntax. Do, var, init, update, test, result, and then expr. When you have an expression followed by ... in the syntax, that means that there are 0 more occurrences of the thing in front of it. So this actually means 0 more expressions. 0 more of these bindings, or these triples, I should say. I shouldn't say it's a binding. 0 more of these tests. Or sorry, the test will be, definitely needs a test, but 0 more results. Anyway, you can read the syntax. So, and then it's got some examples of it. All right, so you can look up do, learn a little scheme that way if you want. I don't use do very often, but if you're doing imperative stuff in scheme, it can be convenient. All right, that's what your part of your micro will be to read this paper, quasi quotation and Lisp. And, if you're just getting started, then this might be kind of hard to read, but, it's written not at a super high level. This is not a paper where you need a PhD in programming language semantics or something to understand it. Okay. You can, try to see as far as you can get. And if you get confused, you can come back to it later. Try to read it again, see if you can get further. But you can see that there are different idioms here. Okay, so this is the interesting part. You can start doing things when you have like nestings of quasi-quotes and quotes and stuff like that. You can have expressions like, unquote X or comma X. But then there are things like comma X and comma quote comma X. Okay. And when you're doing metaprogramming, when you're writing programs that write programs using quasi-quote, sometimes you need these sorts of patterns. Let's see if I can. So you can find this paper. Yeah, here we go. Okay, so this is 2017 ICFP Perl that I wrote with Michael Ballantyne, Greg Rosenblatt, and Matt Might. And in it, we're doing miniKanren relational interpreters, which we'll get to. But the last program in this, so there's 7 challenges, okay? And it's like, hey, how do you solve this challenge? You get a little stop sign. Here's the stop and think. This is like the SAT exams or whatever. I used to have to take like that little stop sign. How do you think this? Stop and think. Turns out all 7 you can solve with miniKanren relational interpreters. What a shock. But in this, we're writing interpreters for scheme or subsets of scheme in miniKanren as relations. And one of these interpreters adds support for quasi-quotation. And so we end up with these weird patterns for implementing unquote. Okay, so see if you can see this. All right, so part of this is racket. Okay, so like racket works a little differently, but here we're using the racket match. And so here we have this pattern. So we're matching on this pattern. So we have quasi-quote, left paren, comma, comma, quote, quasi-quote, unquote. Okay. And there's like a little footnote here about that, I think. Yeah, here we go. The unfortunate representation of the pattern for matching unquote expressions results from an oddity of Racket's quasi-quotation support. In other scheme implementations, that line can be written like this. Okay, much nicer. All right. But I guess my point is, if you're doing kind of fancy things having to do with quasi-quote and unquote, you can see these weird patterns, and I guess Racket has that even more. But like, yeah, that. Oh, wow. Anyway. So there are these idioms, and when you're doing nested splices, so that's one of the cool things about this paper is it has a collection of idioms. Like, here are some patterns that can be useful that you might come up with, like comma at comma x. Okay, comma at is unquote splicing. You can splice in like a list, for example, and then comma comma at. So comma at comma is different from comma comma at. Okay, and so the different ways you might use these things. So it's much, quasi-quote and unquote splicing are much richer than you might think. And there's also some debate about what the behavior should be, like three Lisp. So, it is a whole little mini game, and I think there's open research problems still about how quasi-quote could be used. So anyway, that's part of your macro, is to try to read this paper. Might take you multiple attempts to get it all, but I would encourage you to try these examples. Okay, to try typing this into Shea scheme or some other scheme, and see if you can get these things to work. Some of it might work differently in Racket, so since this is written in scheme, probably would stick to probably an R6 RS scheme. This is kind of an old paper, so maybe R5, but I think this probably all works the same in R6 RS scheme. Else #t. Okay, that looks old. Usually it's #t, so I don't really know which version of scheme existed when this paper came out. That might be R4 or something. So you might have to change a little bit, but I think in general, you should be able to do these examples. So this is a nice one. Nice paper, and it's cited by Shea scheme. So let's look in Shea scheme. Sorry, let's look in the scheme programming language. Let's look here in the index for quasi-quote. All right, so there are actually two entries in the index for quasi-quote. So one is the beginning of the scheme programming language index are punctuation marks, the special characters. Okay. And so for backquote, backtick, that's in the index, and then it's written as, like that's the same as quasi-quote. Okay, that's page 142. Or we can find quasi-quote is in the index, and that, is also refers to backtick. So we can go to page 142. All right, so this is in chapter 6, operations on objects, section 6.1, constants and quotations. Okay, so here we have self-evaluating constants, sometimes called self-evaluating literals, right? So 3.2 evaluates the 3.2, that arrow means evaluates to. #f evaluates the #f. The character C evaluates the character C. The string high evaluates the string high. All right, so this is like a type of vector that evaluates to that vector itself. And then we have a description of quote. and the alternative syntax, right? So we have quote of some object obj, and the single tick character of obj, those are equivalent. And what's the result of evaluating that? It returns obj. Okay, quote of obj is obj. Quote of datum is datum. And it tells you the libraries. So for R6, RS, there are these libraries, and you can say that, we use, instead of writing R6 RS, you write RN RS as the library name when you're importing things. We're not going to worry about that right now. You can look it up if you want. So here, this thing we already knew about quote. So the single quote of obj is equivalent to left paren QOTE of obj. Okay. The abbreviated form is converted into the longer form by the scheme reader. See read. So there's a procedure called read that can be used to read things, you can read from a file or a stream or whatever. So there's something called a reader. And in some versions of Lisp, there are things called reader macros. Scheme doesn't really have reader macros like the Scheme standard, at least our 6 doesn't. Some Scheme implementations might have extensions that give you something like reader macros. I don't know. But in any case, we have an example of something that's kind of like a reader macro where, the Scheme reader, if it sees a single quote obj, it is converted when read is run, it gets converted to this expanded notation. Okay, so literally this gets converted to this according to Kent's book. Okay, quote inhibits the normal evaluation rule for obj, allowing obj to be employed as data. Although any scheme object may be quoted, quotation is not necessary for self-evaluating constants. For example, numbers, booleans, characters, strings, and byte vectors. Okay, so you don't have to put a quote in front of 5. 5 evaluates the 5. Quoted and self-evaluating constants are immutable. It means you can't use set car bang or one of these mutating operators. We haven't talked about mutation really, but Scheme is multi-paradigm and it does support mutation. And so here we just have some examples. +2, 3. That expression evaluates the 5, but quote whoops. Oh. Sorry. Quote of +2, 3 evaluates the list +2, 3. Okay, and the same thing here. There's just the alternative way of writing it explicitly, right? So we know from that description above that this gets converted into this by the reader. That also evaluates the list +2, 3. So in this case, the car of this list will be the symbol plus. Quote of A evaluates the A, so A is a symbol. Quote cons evaluates the cons. Cons is a symbol. Okay, so if you just evaluate cons by itself in Scheme, in the initial environment, you would get back a procedure. So cons is bound to a procedure in the initial environment. But here, if we quote cons, we get back the symbol cons. All right, quote left paren, right paren gives you the empty list. Okay, so the empty list is not self-quoting. You have to put a quote in front of it. Quote 7 evaluates the 7. 7 is self-evaluating, so you don't. This quote is not technically needed. All right. Now, when I say things like empty list, you have to quote the empty paren. Now, I don't know if you have to do that in Racket. Okay, you can test it, find out if you have to do it in Racket, but in R6 RS Scheme, you have to quote it. Okay. Quasi-quote. So here we get to quasi-quote. So that was quote. Here's quasi-quote, unquote, unquote, splicing, right? And so we have these alternative syntax. So we can do quasi-quote, or we can have the backtick character or the backquote character. Unquote, fully written out, or we have the comma. Or unquote hyphen splicing, or we have comma at. All right. So similarly with the reader, that this syntax will be turned into the expanded syntax. But notice something interesting. So I was looking at this the other day. I didn't realize this. Quasi-quote with the backtick, that version takes one object obj, or one datum, whatever you want to call it. But notice that the expanded version is actually written obj ... So 0 or more objects. So you can call quasi-quote, the explicit version, the explicit syntax, you can call quasi-quote without anything in there, without anything between the parens, because this means 0 or more obj. Or you could do it with multiple objects. I didn't know that. I thought you only had to do it with, you could only do it with one. So let's just try this out. So quasi-quote 5, okay, quasi-quote cat, quasi-quote list ABC, all right, quasi-quote list ABC, great, but can I also do 5? Or let's do another list. How about DE? Okay, now this is confusing me. So here's how I'm confused. I know what this syntax means with the ... And here, so they have examples. Yeah, so I am confused. Yeah. Well, okay, so I'm seeing what looks to me like an inconsistency in the specification or I shouldn't say specification. The scheme programming language, 4th edition, that is not a specification. This is not the standard for scheme or the report for scheme. If we wanted to look at R6RS, we have to look at the actual report. Okay, so this is like the definition, if you want to talk about sort of the standard or what we would consider the standard. Whereas here, here's a book that's explaining the language, but this is not normative, as they would say, right? So if there's an error here or inconsistency between this book and the report, you have to go by the report. But the report itself could contain an error. There are also times where Shea Scheme doesn't implement things according to the standard, okay, so for whatever reason. But here, this looks like a more general use of quasi-quote. Now, one thing I'm curious about is whether Racket supports this. So, the other thing is maybe I'm misreading this. No. Maybe I'm misreading this somehow. Let's do the Racket language. Oh, come on. Hashlang Racket. But it does seem a little weird to me. Okay, so ABC. Run it. Okay, get the list ABC back. Okay, let's do quasi-quote. Okay. Now, here you can see a difference, by the way, between Dr. Racket and Shea Scheme, and between Scheme, Racket, and Scheme in general. Notice that when we evaluate this expression, we get back quote list ABC. There's a quote in front of it. You can actually change this, how this is printed out. So the printed representation here is what you would type into the REPL if you want to get back list ABC. But then they always show the quote as well. You can change that. Let's see. Might be under settings. There's a way you can change like how things are printed. I don't remember if it's under here. Printing mode. No. I know, well, there at least used to be a way. I think there is a way to change it, but don't remember where that goes. Anyway, so this is a difference, and this, to be honest, drives me up the wall a little bit because I like the way Scheme does it, and but in any case, let's see, does this quasi-quote support multiple objs? No, bad syntax. Okay. Let me just try something simpler. Nope. What about 0? No, bad syntax. Okay. Now, sometimes I find, mistakes in this book, so I don't know if it's a mistake there. Let's look at R6RS. Let's look at R6. Let's look at the report here. This is all part of becoming really comfortable with the language, right? Like all the little details. And if you don't know something, you recognize something weird, and like, okay, let's track it down. What's going on here? It's like a quasi-quote. Here we go. Pages 56 and 57. Let's look it up. All right, quasi-quote. Quasi-quote takes a QQ template. Huh. It looks like it only takes one of those, whatever that is, though. QQ template should be as specified in the grammar at the end of this entry. Okay, so there's a grammar somewhere. All right, here's the QQ template. What? The following grammar for quasi-quote expressions is not context-free. Okay, well, that's interesting. Is presented as a recipe for generating an infinite number of production rules. Okay, as I told you, quasi-quote's more complicated than you might think. Imagine a copy of the following rules for D equals 1, 2, 3, etc. D keeps track of the nesting depth. Okay, so the thing with quasi-quote is you can nest these things. So if you see a quasi-quote, or it's like if you see an unquote or an unquote splicing, it depends like how nested you are. What those unquote and unquote splicing mean. All right, so here's a template. So I guess we're keeping track of the depth here. So the initial template, great. We're at depth 1. If we're at depth 0, then the expression itself gets evaluated, I guess. Quasi-quote. All right, so this is kind of interesting, first of all. I've never read this part. So we have to keep track of the depth. So we have the depth counter that we're passing around. And also, quasi-quotation can involve vectors, which is something I learned recently. Not just lists, but vectors. So that's kind of cool. Now, I'm a little confused, though, because it looks like quasi-quote can only take one thing. Okay, so yeah, there's a template, but you notice there's not a ... there. And I don't see anything here in the template about having multiple things. I don't see it. So this might be a mistake in the Shea Scheme programming language, the book. Yeah, that doesn't. Shea Scheme doesn't seem to allow you to have only one. I'm sorry, to have 0 or more obj. You have to have exactly one obj. And also, it's kind of interesting that this syntax only lets you support one obj with the backtick, and the expanded syntax would give you multiple. Huh. Yeah, I'm confused. Anyone can shed light on that, I'd appreciate it. But I think it's kind of interesting. I mean, it does say, I think it says in here what that means. I thought that. Okay, unquote and unquote splicing forms with 0 or more than one subform are valid only in splicing contexts. Okay, so they show unquote. So unquote can take 0 or more expressions, and that's something I didn't know. And unquote splicing, it's the same thing. So that part I get. There is a generalization that makes sense. But I don't see anything about quasi-quote taking. And I don't know if that was just a typo or what, or maybe there's supposed to be a generalization. Okay. Now, let's I'm trying to reset here mentally. I was excited to test out the quasi-quote that took any number of expressions, but it seems like it's unquote and unquote splicing that takes any number of expressions. Okay, so let's try that out. Okay, let's just look at an example. So, all right, here we go. Now, I'm going to do something which may or may not work, which is copying from the web page into Emacs. And when you do that, sometimes you get weird behavior because what you think is a backquote character might not actually be a backquote, but it looks like in this case it worked. Okay. Oh, I see. Okay. All right, sure enough, unquote actually can be used with more than one expression and with 0 expressions. Okay, so I didn't know that. But let's say we wanted to do this. Okay, so here we can, with a single expression we want to evaluate, in this case, we can use a single comma, but that comma has to have something after it. Yeah, so that's not allowed. So, well, it's being interpreted as unquote B. So B is being treated as a variable lookup. It's not bound. So that's interesting. So this is the distinction between what you can write that's with the comma that's interpreted by the reader. I mean, expanded by the reader into this unquote form. But the expanded version is more general because you have parens that can delimit things. Okay, so that's something I learned. I don't know if R5 works R5RS works that way. And I don't know if R7RS small works this way or not. I don't know. Could look those up in those reports. But anyway, that's something I learned I didn't know about. Yeah. And what else here? Well, this is your ladder homework from last time, was to go through the section. Right, so I'll put that in for this time again. So hopefully you got some sense of this from before, and you took a look at this, but I just want to make sure. Whatever. Yep. In case you haven't done it, this is another chance to do it, okay? Just getting used to reading the report and try out the examples in ShaScheme. And then optional, try out the examples in Racket. How do they differ? How does the behavior differ? If at all. And like I said, there is a way. I know that you can do it with like the parameters or whatever in Racket. You can change how the printing works. You can change how the printer works so that quote you get back is suppressed, and so it behaves like it does in Scheme. So you can figure that out or not. You could do that or not do that. Or you could just get used to reading it the Racket way, but just be aware that Racket does print out these quoted values differently than does ShaScheme. So anyway, go through there, do what I did, try out some examples, right? So like I looked at the Scheme programming language 4th edition, and it told me about what the syntax was, and I was surprised to find out I got a syntax error. So I still don't know what that is. I suspect that was a typo for the quasi-quote form. Just trying to, hey, unquote and unquote splicing have ... And it's probably just an easy error to overlook because quasi-quote doesn't seem like it supports ... And from the R6 report, I didn't see any evidence that you have ... support. We could have 0 more. So anyway, that's the sort of thing where I'm talking about where we want to learn the core parts of this language inside and out. So for R6, I don't know. That I'd never seen that part before. And I learned about the generalized unquote and unquote splicing. I don't know if those were supported in R5. I don't remember seeing that before. I don't think I've ever seen it in the wild. And also in the Scheme programming language, it says that the unquote and unquote splicing form that takes multiple sub-expressions or multiple objects expressions that tends to be used for the internal expansion of quasi-quote. So that almost feels like implementation detail leaking out, but it does seem like it's maybe useful for other purposes. Like if you're doing really heavy metaprogramming with quasi-quotation, maybe that's a useful thing. But it also sounds like, hey, this is something that's really useful when writing the quasi-quote expander, so it's nice to have in the language. Learn something new. Okay. I think that's it for now. I was going to do all sorts of cool quasi-quote stuff, but I actually think this is kind of more interesting. It's like, all right, look it up in our TRS or TSPL 4, and you try something out, and it doesn't seem right. So, okay, look at the report. The report seems to have a different version of it. Try it in Racket, which is not Scheme. But Racket also doesn't support that generalized form. So I think that's probably a mistake, a typo. Books have typos, and I have found other typos in the Scheme programming language. So, sometimes the Scheme report has mistakes in it. Anyway, yeah, I'm not sure what to do about that. So back in the day, I would just email Kent. I'm not sure Kent's maintaining that book anymore. I'm not sure. So maybe I'll email. I might email some people working on Shea Scheme to see if that was really a mistake. Good to know. Well, once again, this is like I said, as a researcher, the undergraduate mindset is show me the textbook so I can learn about this. Well, I mean, the real undergraduate mindset is I'm not going to read a textbook. Go party. Maybe that's one level. But another level is, show me the textbook and, maybe I'll look at it. Another is show me the textbook and I'll read it. Another level is show me the textbook and I'll do some exercises. Another level is show me the textbook and I'll do every exercise. Another level is show me the textbook and I'll do every exercise, including the ones that are, involve like open problems. But then, that keeps going, right? And then another level way above that is you write the textbook, right? Because you're doing the original research. And somewhere in there, there's also a level of you are reading books and reading papers in the process of understanding things and finding mistakes. And then beyond that is you think you found a mistake. Now write to, the author or authors and see if that's a mistake. And if so, they'll appreciate, hopefully, that there might be a correction, or maybe they clarify, what the difference is. Maybe it's a mistake in your understanding. So, and, Donald Knuth very famously, has a policy of giving checks out to people who find mistakes in the art of computer programs. There's a long history of people framing their checks from Donald Knuth. So, that's just the way of it, right? Just because something's written down in the book, even by someone who is the editor of the spec, doesn't mean that the book doesn't contain any errors, right? And so what do you do when you find something that might be an error? How do you find out if it's an error? And then do you let the person know? What do you do? Or, that's part of the sort of fractal complexity of everything, right? Was it the unreasonable amounts of, what was it, like this essay that reality has an unreasonable amount of detail or a surprising amount of detail, right? That's the kind of thing. All right. Well, that feels authentic to me, right? Like, hey, let's look at something up in TSPL, and we got confused right away. Try something out. This is really cool. And then, but then I did learn something about the other two, the unquote and unquote splicing being more general, but only when you use the fully expanded form, not the comma or the comma at form. That's really interesting. And I don't know that R5 had that. I don't remember reading that in the R5 report. Yeah. That's something you could do if you want. See, is that in R5? Is that in R7? R7 small. Okay. Well, you've got your laddering practice to do. And, if you find some great resource that you find inspiring and interesting and that gives you a new perspective on living a creative life, please share that with me. I'm always looking for those things. Okay. That's it. Happy laddering. I'm happy to make another episode after a long break. So hopefully I can keep making episodes, but that's the thing about doing something creative, right? This is a creative endeavor. It's like not every day is equally good, and sometimes you're distracted, and sometimes you're like, oh, it's just not coming. And so this is living what I'm talking about by making this series. All right, hope to talk to you soon. Bye-bye.